What's up, Mananap? Good day. Welcome to Code Conyo. For today, I'm going to discuss about linked list data structures, or shall we say linked list algorithms. So, one of the contributing factors or influences with the rows of linked lists is the idea of or the drawback of arrays. Because as we all know, arrays allows to only store limited values rather. So meaning to say we have to know how many values or elements we are going to store in our array before we can actually write a program. So that would mean that array is fixed and we are only allowed to store data based on the size that we specified for it. Okay. Now, when we talk about linked list, this is a flexible dynamic arrays in which we can actually store as much as data as we can, and we can store the same with arrays. We can store our data or elements at the beginning, in the middle, at the last, and however, this linked list algorithm or data structure is a dynamic arrays in which, as I've said, we can actually store data as much as we can. So linked list is actually a built-in data structures in Java or data structure in Java along with or a family of list algorithms. So it's basically a child of algorithms along with linked list algorithms rather, along with stack algorithm, array list, and vector. So that we have actually discussed in object-oriented programming. But this time we're going to focus on the linked list algorithm. So in linked list algorithm, again, we can store at the beginning, we can store data at the beginning, in the middle, or at the last, and even we can remove data or element any uh, any what we call this one at the beginning, at in the middle, or at the last. Okay, so this time I'm going to show you the built-in linked list data structures, and later on I'm going to discuss about or give you a tutorial on how to create our own ADT that simulates the idea of linked list. Okay, kumbaga we are going to do a reverse engineering on linked list ADT. All right, so to start with, I have here the class which is named as test linked list, and then I am going to instantiate now a my list. So let's say I have here linked list. Okay, so don't mind this one. This one is actually stands for an element. So this would how do I say this? This would actually indicates that we are actually going to store specific element or value to our list, whether we want to store only integer, we want to store only string or double. Now, the same with vector and array list, of course. Now, let's omit that one for a while and let's go directly with the instance of our array list. And then we have here linked list. Okay, so we can also like remove this one. Okay. Now, so let's have the first operation of array list, which is to add. Okay. So add means add is an operation of our linked list, which is the same with array. We can store data or element, or we can actually insert element to our list at the this would be by default at the end of the list, because this is just add, meaning this is the usual, or this is kumbaga, the ideal in adding a data to a list. So now I'm just going to add this one, so I can add data like let's say marked. I can also add data like for an instance, I am going to add an integer value. So let's say 12. And then I can also add value like, double value or with decimal point. So this would mean that our list is actually a variant type, which means we can store whatever data we would like to and as many as data as we can. So if we are going to display a particular list, we can just go directly call the object of linked list. So to run this one, we can simply run. I mean, of course, no. And then you have here mar 12 and 5.0. So all added in a linear list or sequence manner. So mar 12 5.0. Now, what if we are going to use the or call the operation of a linked list which we can add at the beginning. So to do that, we can just simply call add first. So the add first method is going to allow us to add a data or element to a list at the beginning of the list. So I have here, let's say add first, and I'm going to add Ivana. So right here, if I'm going to display the list, or my list now would have elements that is expected uh, to show the list here that Ivana comes first or comes before Mart and all the rest of the list because we just added Ivana at the beginning of our list. So every time you add at first, obviously this would uh, let's say 100. This would be inserted or added to our list at the beginning of the list. Okay, so that is add at first. So meaning to say, the the head now is our head now is 100, and our tail is 5.0. Okay, so that is add at first. Now, uh, we can simply add or call add at last. Add at last and add are just the same, only that when we talk about add, this is actually a value returning type which actually returns a boolean or which either gives us true or false. So just like for an instance, if I'm going to add an object, let's say up here, um, let's say aria star. Okay, so since this gives or this returns a value, whether the a value or an element is inserted successfully or not. So we can, to prove that, we can actually call system that out that print or that print line, and then ll dot add aria star, and this would return true or false. Return true if successful, return false or if not. So we can call this one here the list, and then Arya Stark will be added or appended. Appended, is it right? Is it the right grammar? Will be added at the end of the list. As you can see, you have Arya Stark. And this, as I've said, line 20 gives us the return type of, or the return value of true, meaning the Arya Stark, or meaning Arya Stark is actually, or was actually inserted successfully to our list. Now, another way to add the list is, of course, you have here the add at last. So I told you about add and add last are just the same, only that the add last is a void method. So meaning to say, this method is not going to return any. Okay, so this cannot be put in between system dot print line. So you can only call the method directly. So for an instance, we're going to add our, let's say, Jan Snow. Okay, so add last. So add here, the same with we have right here, same with what we did right here and also here, only that add is, again, it returns true or false. So we have ill that add last is adding Jon Snow at the end of the list. Now, of course, we can add the data or the element Jon Snow at the end of our list. However, if I'm going to like put this like the way I did this one here, and then I'm going to use the add at last. Okay, so the same I did it here in area start. So obviously this would give me a an error. It's because again the method add last or the method print line, it's a giving either it's actually a print stream that is not applicable for the arguments void. So therefore we'll need to remove. I mean we'll just call, if you're going to use add last, you just have to call it directly, and you cannot do it the same way we did at line 20, which is as we have right here, we just added aria star. So again, take note on that. So add and add. Okay. So now, how about if we're going to add a certain value in between two lists? Okay. So to do that, you just have to call the add. So we have here add with the boolean and then add with the void method. So these methods are actually method overloading, which is a in the principles, this is principal polymorphism, no, object-oriented program. In object-oriented programming, we have the same method name but different behavior. The behavior of the other one is actually Boolean and it returns true or false, while the behavior of the other one is actually void and it has two elements or arguments. If we're going to be using this one, meaning to say we are going to store or add a list to our linked list or to our existing list using a certain index. Let's say for an instance, you want our element to be inserted at the let's say LL. Let me show our list. So let's say for an instance we have here zero. So by the way, it starts at zero, zero, one, two, say three. So let's say we are going to add the value right after mark and before 12. So that is 0, 1, 2, 3. So all we just need to do is use the index 3 and then add an element. So let's say for an instance, this is Cersei. Okay. So if you're going now to display your list, you would have inserted or you would have added Cersei in between Mard and 12 as list, okay, or element. Okay, so that's how you add in the middle. So now, what about if you're going to add or you say you call this method and then let's say for an instance we have here 0, 1, 2, 3, 4, 5, 6, 7. So 7 and then we insert this at the end of the list. So let's say for an instance, I'm sorry for I am going to copy this one and then let's say let's how much is that? One, 0, 1, 2, 3, 4, 5, 6, 7. So meaning I'm going to insert it at like at 8. So meaning there's no index 8 in our list. So let's say if we are still able to store this value. Okay, so let's say for an instance this is Cortana. Okay, and then let's see if this will be added to our list. Yeah, so it will be automatically added at the end of the list if you're gonna be using or if you're going to use an index that is going to exceed in the length of the our list. So the same with other list algorithms. Again, you can call the list like its size to know the size or the current size of the list. Okay, so let's say for an instance we have here size. Okay, so you can just call the size, which is the size of our list is 9. Okay, now how about if we're going to remove? Okay, so let's remove. So you simply the same way with what we can do in array list vector, you can actually call LL, sorry, linked list that remove. So you can remove. So this would remove and retrieves the head first element of this list. So this would return the head of the list because as you can see here, it's an object. So of course, if you're not going to like you're just going to call directly ll.remove, and then the next time you will actually display the list. Okay, so since we just added Cortana recently and then we call the remove is actually, uh, as you can see in the in our list, we have here we have Cortana. Okay, so remove. So right here, we just remove the 100. Okay, the first element. So we have here remove. So removes the head. Okay, as I've told you, head, the first element of this list, not Cortana by the way. Okay, so there, remove. If you're going to put this one here or here in the print line, it could be possible because this is a non-void method. So meaning this is not a void method. This returns an object. So it is just going to return 100. So you can say something like 100 is or was removed from the list. So let's call some. So we can you can have here remove first. Okay, so remove and remove first are just the same, only that yeah, so they are actually the same, only that uh, they have different name. Okay, so it removes and returns the first element from the list. Okay, now if we're going to do that, remove first, and then we call the here we call the list, and then I know. Okay, all right. So that we are able to keep track the removed values or elements. So let's say remove, okay, remove last, okay, and then remove at specific index. So right here, we are going to copy paste this one, and then let's have here, uh, sorry, remove. Okay, so let's say the other remove is you're going to remove at certain index. Okay, so you can have here, you have actually three methods right here, which are overloaded remove. So the remove doesn't have the remove which doesn't have any parameter, this would automatically removes the head. So the same with the remove first. Now the remove index, this would automatically, or this would remove a certain element through an index. And the remove object, this would display, or I mean, this would remove or delete the elements or element using the element itself. Okay, meaning you're going to use the element that you will need to delete. Okay, so for an instance, I'm going to delete via index. So let's say I'm going to randomly I'm going to delete a tree, and then I am going to delete, let's say, Cersei. Okay, so Cersei. Yeah, here Cersei. All right. So let's see if we are going to delete Jon Snow or Ivana. Uh, Ivana. Okay, so let's say we are going to delete Ivana. Anyway, let's stick to this one muna. Okay, so at first, so we have 30 at line, go directly to line 38 right here. So you have remove ll that remove, so 100 is actually removed, like so that is why upon listing the current or the elements of our list, we don't have anymore 100. So next is we just call at line 42, we have remove first. So after removing first, we don't have Ivana anymore. So that's why we have Mart, Cersei, 12, 5.0 star, Jon Snow, and Cortana. And then let's say at line 45, we call the remove last. So from the our list, we have in our line 44 or 43, we still have Cortana. But after line 45, that we actually removed the last element, so that's why we now don't have Cortana in the list. And then based on that list, so we have here 0, 1, 2, 3. So 5.0 is at index 3. And as you can see, 48, we remove the index 3, or we remove the element at index 3. And then that's why after that, we now don't have 5.0 in the list. And then after that, the last one is we remove Cersei, and then we actually remove Cersei in the list. So what if, okay, what if we are going to add, okay, so let's say, I mean, remove the list. So let's say we are going to remove Arya Stark. But this time we are going to use, I mean, we are instead of capital letter A for Arya, for A, first letter of the word of the name of Arya, we have here Arya Stark. Let's say if this one will be deleted. So as you can see, Java is a case-sensitive programming language. Therefore, the data Arya Stark is, or element Arya Stark is not going to be removed because it has to be it has to be a correct match of Arya Stark. Okay, so few of the list, few of the operations that we can see in the list are clear, get, so we can also get value. So meaning to say, if you want to like uh, okay, you want to know or to get the value at specific index. So let's say for an instance, I want to get index 2, and then I want to get the first. I want to also get the last element. So you can do that. Okay, get last. And then what do we have here? So you have here the element, and then uh, the peak, okay, and then yeah, so we can actually just call all of this. Let's say ll dot peak, okay, and then so peak in data structure like stack is the value at the top, and then peak in queue is the value at the first, no, the element that is about to be deleted. So in linked list, retrieves but does not remove. This is going to display the head, but it's not going to remove the list. So the same with the pick first rather. So it's also going to display the first element or the head of in our list, and then the pick last is going to um, display the last element in our list, and it's not going to remove. And we have here Paul first. So this is going to remove the head. The Paul first, this is going to remove also the head. And then Paul last is also going to remove, I mean, this is going to remove the last, of course, obviously. And then you have here is empty if our list is empty. And you can actually call as many as you can. And the only thing that you're going to do right now is just have uh, to you know, mm, get to know with the method by looking at the what they call this one, the doc comment. So there's one more that I'll need to discuss in linked list. So I have here ll dot. So you have here set. So set means it's going to change, rather than removing or adding a list or an element of that list. We can also change or up or like modify a certain element. So this time we can change the element at a certain index. So let's say for an instance, let's look the our list. So we have here Arya Stark, and we are going to change this to Sansa Stark. So we have 0, 1, 2. We have set 2, and then the value now should be Sansa Stark. All right. So, and then I'm going to call. So by the way, the same with what we can do in vector and array list and stack, you can also use the loop all throughout your list. So from here, you can have, let's say, ll dot size, and if you want to, display the list through, like for an instance, I have here ll dot get I. Okay, so there you are. And then if we're going to run our program right here, so from here, you have here some of the, this is Arya Stark, this is get two, and then Mart is get first, and then get last is Jon Snow, pick is Mart, and then LL that pick is false. It's going to, the pick, by the way, is going to return, uh, it's going to does not remove the head first element of this list, and then is empty, is going to return either true or false. So since we have currently our list as elements, therefore it returns false. And then you have here, after line 63, we have Sansa Stark being changed to, I mean, the index 2 is being changed to Sansa Stark. So this time, that's why here we have Sansa Stark. So Arya Stark is now replaced, or it's now modified or altered from that value to Sansa Stark. And then we just simply display, or yeah, display the elements of that list through loops. So you have here that using that get. And you can also use um, what they call this one, a, a for each loop. So for an instance, you are going to use for each loop. So let's say right here, so object val, and then through the list, you can just use val instead. So this time, okay, and then let's print. I think let's have the val, and then okay. mm, yeah, so I will have to display system out the print line here, and then I would have here the val. So all the list of that linked list, or all the elements of that list, will be passed through val, and then the val now will be used to display the elements of our list. So there you are. You're able to display Mar 12, Sansa Stark, and Jon Snow. Now, one more thing, as I've told you earlier, if we're going to, explicitly declare our list to be like an integer only, so this would mean that all those, you cannot add a string anymore. You cannot add a double value anymore. The same with what we actually did in array list and vector in OOP. So you have here, so you need to, remove all this one. So in a similar manner, if you're going to like use only double, so right here, you cannot store data except for double. So you can also do that for string. And we are going to do that and implement that. I mean, we are going to create our own ADT that does this kind of uh, uh, operations, or doing this kind of processes or mechanisms. So that's it for the linked list. What we call this one, linked list built-in data structure, or ADT. And then in my next tutorial, I'm going to discuss about how to create our own linked list ADP without using the built-in linked list in Java. Okay, so that would be all for now. Thank you for listening and watching this video. This is Tonyo, and have a great day. Don't forget to subscribe. Bye bye.